I'm Zach Ziegler, and you're listening to Oregon Rainmakers from KLCC. On this edition, I talk with the head of the company that's moving into one of Eugene's largest buildings. On Eugene's far west side sits a massive building that's been vacant for more than 15 years. The 1.2 million square foot industrial building opened as a semiconductor manufacturing facility in 1998. The South Korean company SK Hynix spent more than $1 billion building it, but shut down the factory within 10 years of it being opened, laying off about 1,400 workers. Since then, the building has been bought and sold a handful of times. In 2020, it was bought at auction for $6.3 million. Its new owner, Stratacache, an Ohio-based digital display manufacturer. The company has spent the years since then renovating the building. Today, we hear about that process from Stratacache CEO Chris Riegel, who is in town for an update on the work and stopped by KLCC Studios to give us an update on the facility. He starts by telling us more about Stratacache.
We focus on what we call advanced digital displays. So a display that you would see in a retail environment, a bank environment, a screen that's impacting a consumer and helping that customer choose a product, make a suggestion, things such as that. And we've been doing that close to 30 years now.
How big are we talking on screens like this? Is this getting up to, billboard size when you see the digital billboards, or are we usually talking more, maybe what you see at the airport, things like that?
Yeah, typically what you'd see in the airport in a retail space, in the billboard size, the Chinese manufacturing infrastructure is really well suited for those big mass environments. And it's honestly kind of overbuilt and subsidized by the Chinese government, so very difficult to compete in that space.
So about 5 years ago, your company bought a property here on the southwest side of Eugene. It was formerly a semiconductor plant. What's the status of that facility at current?
Yeah, absolutely. So we bought that in Q2 of 2020, and through pandemic, spent all time, money, resource in starting the renovation of that facility. Hadn't really been touched in 12 years. So with that, we're now starting to bring in pilot line equipment to make what are known as micro LEDs in that facility.
Okay, so that's going to be my next question. What part of the product is this? The screens are rolling out, or is there a specific part of your screens that you'll be making here?
Yeah, so there's a next generation screen technology called micro LED. Micro LED is making, think of like if you were a kid of a certain age, you used to play with a light bright, and you could create a pixel on a screen on your phone, on your monitor, on your tablet, is nothing but a very, very small light bright. Effectively, we're making those pixels here, and in that next generation of what micro LED is, that's at 5 by 5 or 5 by 10 microns, or millionths of a meter. So you're making very, very small objects at an incredible precision, and then stitching those together to drive a display. Today, in cars, in your home television, in any other use case for display, they're incredibly inefficient to energy. So micro LED is up to 80% more efficient. Can do things like being transparent or translucent when not in use. And there's a whole series of applications for that kind of all across the spectrum.
That's kind of an interesting technology, actually. So on top of it, having these uses, it sounds like it's also something that is kind of future forward in that helping with using less energy.
So the sad way to think about it is in the United States, there are no display fabs. There's no display manufacturing. So if something bad happened in that supply chain, and that supply chain today is 95% domiciled in China, you would immediately lose the ability to have displays. Now, displays can be your television at home, but that can also be the display in a F-35 fighter or in a weapons system. And everyone will look to the bad side, but it's strategically important for the U.S. to have a display capability within the United States and not have that dependence on China.
Yeah, think about any time you see, in a movie, a representation of some situation room or something, they always have screens everywhere. That's something that if you stood to lose it in a situation like that, it would be pretty mission critical.
Humans process data visually. So in the use case, if you think of all the money that's going into AI and data centers globally, having all that capability is cool, but you still have to have something to see that result from. And as you get into, now you're seeing more augmented reality, virtual reality, enhanced reality use cases. There are millions and millions of critical uses in display, from medical to transportation to military to pick, educational or other. So display is a fundamental building block, and unfortunately, the U.S. hasn't had a really great focused industrial policy over the last 3 decades. So all of that offshored. Now we're one of the companies trying to bring that back to America and doing that here in Eugene.
Yeah, that was actually something else I wanted to ask about. Ever since really the 90s or even before, there's been a lot of talk of manufacturing moving overseas. Why build this here in the U.S.? Also importantly, why here in Eugene?
Yep. The factory itself, what we call the Hynix E4 fab, was sitting unused for over a decade.
Mm-hmm. Before that, someone pumped almost $2 billion, I think was it's like $1.8 billion into that building.
In 1990s dollars. So you're probably close to $5 billion today if you want to build that facility. So fabs don't come along every day. A fab is a strategic resource within an industrial policy. So the ability to say, hey, we're going to reuse that existing fab, that fab would not be viable. So if I'm Intel, and you see what Intel's built in Chandler, what they're building outside of Columbus, Ohio, those types of fabs have completely different characteristics. Higher ceilings, different load ratings because they're taking bigger tools. So the Eugene fab was not viable as a semiconductor fab, effectively moving forward. But for micro LED, where we use different tool sets, different use cases, it's absolutely perfect.
We're going to take a break. I'm Zach Ziegler, and you're listening to Oregon Rainmakers from KLCC.
I'm Barbara Dellenbach, host of KLCC's Oregon Grapevine. Divisiveness and conflict are all around us. Lisa Swallow of Crossing Party Lines is helping people on all sides trust each other.
We don't have people modify their views, but we do teach people how to share those views in a way to make someone interested and curious as opposed to defensive and angry.
Nurturing curiosity and conversations on the latest Oregon Grapevine at klcc.org.
We're back. I'm Zach Ziegler, and you're listening to Oregon Rainmakers from KLCC. Our conversation with Stratacache's Chris Riegel continues. Thinking about those tools, I'm guessing you're buying up lots of manufacturing equipment to go in there. That's something that's not necessarily made in the U.S., speaking of not having that priority anymore in U.S. manufacturing. Has anything stood in your way with getting this facility going up in regards to that, be it just the hassles of getting things from overseas, or even nowadays you hear a lot about tariffs on things like this?
Yeah, most of the tools that we need are domestic tools, and if they're not domestic, they're sourced from Japan or Germany. So your main tool providers are still Western, principally. The biggest challenge is simply capital. To outfit a fab like that, you're $2 billion. We are in the CHIPS Act submission under the federal program for chips, because this does qualify under that, but that has been kind of up in limbo since the election. So that's one kind of open point. That being said, there's a big secondary tool market. We've been buying tools in the secondary market, getting that pilot line up and going. And as the strategic proof work that we have to do as we're scaling this out validates great results, and we're starting to see some good results already, then we're confident that the finance will be there.
All right. So you're doing something that a lot of people want to see. You are building high-tech manufacturing in the United States. What has stood in your way in this process, and why don't we see more of it?
So I think the biggest thing that stands in the way of the entire tech industry is governmental understanding of the kind of rules of the game. So a TSMC is the most advanced manufacturer in the world of chips. And think of Intel, right? Intel is a heritage company for Oregon and strategically important. People will say, well, TSMC is much more further advanced and doing cooler things, but they don't understand that TSMC has gotten $190 billion in support from the Taiwanese government over the last 20 years. In these chip wars, there are huge capital investments that have to go in. There's huge strategy that has to go into it. The U.S. is kind of late to the game in understanding. Now, you've seen in the last kind of 4 years, the CHIPS Act and government understanding that, hey, this is important. I spent a lot of time in D.C. with politicians, and the best explanation that was given to me was the senator or congressman from Kansas didn't really understand how important chips were until the Ford dealer down the street called him and told him, hey, I can't ship F-150s because we can't get chips for the trucks. Then it became strategically important. Then it was more relatable. So you're starting to see more government support and more government understanding of it. But really that gap is that educational gap within legislatures of understanding how important this is to the bigger strategic economy.
Yeah, it's one of those things. Everything nowadays is a computer. That's the first thing you do when any product you have doesn't work is the old IT, did you turn it off and turn it back on again?
Correct. Yeah. And that can be something from your Roomba or your refrigerator to the most advanced military or medical or research system. Chips are fundamental to everything.
So when this Hynix plant closed in 2008, it took 1,400 jobs with it. What will this facility look like in terms of jobs, economic impact for the Eugene area?
Yeah, it's a great question. So at peak in the direct manufacturing process, we anticipate 400 jobs. And then as we're building secondary products around the platforms from MicroLED, there could be another 400 in secondary jobs coming from the plant as well.
And what's the time frame look like for this all for you guys? It's been a bit of a process, I'm guessing. 12 years of dust to knock off and rodents to kick out of the building.
Yeah, nothing is easy at fab scale, I'll say that. So we're going into pilot line in 2026. With pilot line in 26, then we start to scale out production lines in 27 and 28.
I think that's all the questions that I had come up with to ask you on this. Anything I didn't think of, though, that's important to talk about on this topic?
I think just one thing is to understand within the state of Oregon. Oregon obviously has a huge heritage in chip manufacturing, and you see specifically in Beaverton, all the Intel points. Oregon is a great partner for chips companies to say, hey, the infrastructure's here, the human capital's here. And I think one kind of good story to tell is to understand that for others looking at manufacturing, Oregon is a great place to do advanced chip manufacturing because of the human capital and the capabilities and the partnership with the state to bring those great jobs and great economic booster to the state.
All right. Chris, thanks for joining me today.
Thank you.
That was Chris Riegel, the CEO of Stratacache. This has been Oregon Rainmakers from KLCC. I'm your host, Zach Ziegler. Thanks for listening.